Well, hello grade 12s, and welcome to another lesson on on electrostatics, okay? So anyway, guys, there's only 2 lessons left. I thought I would do one of them today and maybe do both. I'm not sure. We'll see how long it takes. Anyway, first, I want to tell you about this guy, Millikan, okay? So Milliken was a guy who lived about 100 years ago, and he's famous for a single experiment, okay? And I'll see if I can zoom in on this experiment here. What he did was he took a pair of parallel plates, okay, and you'll notice in this case the top plate is positive, the bottom plate is negatively charged, okay, and what he did was he sprayed drops of oil, okay, really tiny drops of oil into the apparatus, and it was sort of a, he sprayed it through a hole, okay, that was in the wall of like a little cylindrical chamber, okay. Now on the other side he had a magnifying glass, okay, that he could look and peer into the chamber, and there was a light source inside, and then there was a wire that was used for scale. But anyway, that doesn't show everything here, but it doesn't really matter. The goal of the experiment, I'll write all this down shortly, okay, but the goal of the experiment was to determine the charge on the electron, okay. So it had widely been guessed that the all electrons would carry the same charge. So in other words, were electrons like balloons, where balloons could carry different amounts of charge depending on how much charge they carry? Or were electrons all identical, okay, each carrying an identical amount of charge? And if the electron's an elementary charge, does that mean like then any other charge then would therefore be multiples of that number, okay? So like for example, let's say the charge, okay, I'm going to make up a number here. Let's say the charge on the electron was 3, okay, -3. Okay, that means all charges would have to be multiples of -3, right? Like you take an electron away, you'd have a +3 charge. You know, you take you add an extra electron, you have a -3 charge. 2 extra electrons, -6. 3 extra electrons, -9, and so on. Now, that's basically the principle. So what Milliken did here is he sprayed oil drops in there, which became negatively charged when they passed through a grounded like sort of screen, okay? The oil had a high affinity for electrons, so it picked up electrons from the grounded screen and became negatively charged. Then they're sprayed into this apparatus. The negatively charged drops will be repelled from the bottom plate and attracted to the upper plate, but there's also gravity, okay? So gravity would tend to pull them down, but the negatively charged drops could, you know, be suspended, okay? So we're going to look at the experiment involving a stationary drop. All right, so remember, okay, and I'll write it down again later, but the goal of the experiment is to determine the charge, okay, on the electron. Now, in order to do the math for this, we're going to have to look at parallel plates, and we've only looked at it in a cursory way, okay, up to now, but we're going to change that today, okay? So the first thing you do to get the experiment going, we've got our power supply here set at 10 volts, and then what I'm going to do is I'm going to spray some oil in there, okay? So there goes the oil drops. Some of them have a very strong negative charge, okay, and they will go up to the top, all right? Some of them have they're neutral, let's say, and gravity will pull them to the bottom, okay? But some of the drops, depending on the voltage, okay, have just the right, like, you know, you can tweak the voltage of the power supply, right, just with a knob, and at just the right voltage, you can get a drop to hold still for you. So there you can see that drop just holding still. It's in equilibrium, okay? And if you look at this, I'll explain these, forget the electric force formula there, we're going to get back to that shortly. It's not the letter E, we've been using epsilon for the field intensity, so we'll get back to that, okay? So they're in equilibrium, so that is a free body diagram of the oil drop, gravity pulling it down, electric force pulling it up, and the goal for Milliken is to determine Q. And what he did is he did this with hundreds of drops, okay? And he was looking for, some of these drops only had like 5 or 6 or 7 excess electrons on them, okay? And so if he could figure out sort of the greatest common factor, right, of these charges? Would that be the charge on the electron? Okay, that's the premise of the experiment. Okay, so Millikan's oil drop experiment, that's basically the apparatus here like this. And what I'm going to do is I'm going to copy a little picture of this and put it on OneNote, and then I'm going to start another video using the OneNote software. Okay, so I'll get to that in a second. Alright, so that's it for now, and then I will come back to you with another short video, or in a moment with a longer video explaining how we do the math for this. Okay? Alright, talk to you soon.